Okay, in this presentation we're going to look at the convergence test for two simple examples. So what we have here is a series from n equals 1 to infinity of 2n minus 1 over 4n plus 3. What we want to do is check, is this divergent? Is this series divergent, so to speak? So what we do is we would evaluate the limit as n approaches infinity of the general term. So there we have it there. The limit as n approaches infinity of 2n minus 1 over 4n plus 3. Just make sure I have it right there. So if you were to put in infinity here, where n is, you get infinity over infinity, which is an indeterminate answer. So what you would do in this case is you divide by the highest power of n for each term. So 2n divided by n just gives us 2. Minus 1 divided by n gives us 1 over n. 4n divided by n gives us 4. And plus 3 over n, limit as n approaches infinity of that. Alright, so the limit as n approaches infinity of that goes to 0, that goes to 0. So we're just left with 2 over 4. Now, the thing about this is the limit is 2 over 4. If it was divergent, essentially it's not equal to 0. Or it's actually, the limit is a half. And that is not equal to 0. So we can say it is divergent because the limit is not equal to 0. So the answer is yes, this one is divergent. That doesn't look great, does it? Yes. So, got another one. This is a similar exercise. These are from two past papers. Same setup again. The general term is n plus 5 over 3n plus 4. What we're going to do here is again find the limit of that. And again, this is in terms of n. So n plus 5 over 2n plus 4, 3n plus 4. The general divide above and below by n, so we have n over n, that's just 1. 1 plus 5 over n over 3 plus 4 over n. The limit as n approaches infinity of that goes to 0, that goes to 0, so we're left with 1/3. Okay, and again, that's not all. That's limit is not 0, therefore divergent. Series is divergent. Alright, that's the end of that one.